So what we've got here is a picture of a sphere which represents the Earth, and we've just labelled a few things on it. Let's have a look at what we've labelled. We have labelled the centre of the Earth, which is right in the middle there, and we've also drawn on a couple of points on the outside of the Earth, and we'll talk about these in just a second. Now what we can also see on this big sphere is some lines. Now the green lines represents our latitude, and the red lines represents our longitude. So these lines are imaginary lines across the surface of the Earth, which help us to calculate distances and many other things from one point to another. So we would have the South Pole down the bottom here, and we would have the North Pole at the very top. And what we have in our little diagram is, like I said, the center of the Earth, and we've labeled two random points on the outside or the surface of the Earth. And what we would have, one of these orange lines would represent the radius of the Earth, because of course if I drew one line from one side of the Earth to the other side, one straight line, we have one big circle, so that long line from one side to the other would be the diameter. So from here to there, that is our radius of the Earth, and the radius is always what we use in these questions. We use 6,400 kilometers as our radius. So what can we do with all these latitude and longitudes? Well, we can measure distances. For example, we could measure the distance from point P that I've labeled here to the equator, let's say, and we'll have a look at how we do that in just a moment. So the equation that we use, or the formula that we use, is the arc length formula. We need to have pi times the radius, which we said was going to be 6,400, times theta, which we are going to work out in just a moment in a few examples, divided by 180. So it's our arc length equation. So what do these latitude and longitudes mean? Well, I've got here our coordinates for Melbourne, the city of Melbourne. The coordinates are 37 degrees south, 145 degrees east. The first number that we're always given is always the latitude, and the second number that we're given is always the longitude. You can probably guess that these latitude and longitude refer to how far north or south you are of the equator, or how far east or west you are of the prime meridian. So let's have a look at what these actually mean, what all these words mean. First up, latitude. As it says, we always measure it from the center of the Earth to the north or the south. So in our little diagram, we have Earth here that's been cut in half. We've got a few things labeled: the South Pole at the bottom, North Pole at the top. We have our equator going through the middle, and our equator represents 0 degrees. So latitude, these are the flat lines that go across the Earth. The equator is one of these lines. Now they are invisible lines, like we said, but we can use them to measure distances. The equator, 0 degrees, we use it to measure and to calculate the angles between one point, for example, 45 degrees north, and another point somewhere, for example, 45 degrees south. Now what we do is we turn these diagrams into something that looks a bit more familiar and a little bit easier to work with, and we look at it in terms of circles. We have 2 points drawn on our sphere, on our diagram, point A and point B. We're given the, not the coordinates, but we're told how far north or south these 2 points are. Point A is 30 degrees north. That means that it's 30 degrees away from this equator. Point B is 30 degrees south, meaning that it's 30 degrees away from the equator again. So what we can do to help us visualize this in a much easier way, we draw some great little pictures, some great circles to make it look nice and simple. So we have the center of the Earth put in, that's the middle of the Earth. I've drawn on the North Pole and South Pole, as well as the equator, to just give us a bit of an idea of what we're looking at. So it's basically a cross section of the big diagram, the 3D diagram up above here. We have our first point, point A, drawn on 30 degrees north, and that's 30 degrees north of the equator. We have point B drawn on, which is 30 degrees south of the equator. So the type of question that we would be asked in this kind of a situation would be, what is the distance from point A to point B? How far away is point A to point B? So what we're looking for here, the only thing that we need to work out is basically the angle created between point A and point B. So if we know that point A is 30 degrees north of the equator, point B is 30 degrees south, we can easily work out the angle in between. So if we would continue our little equator line there, from point A down to the equator we have 30 degrees, that's what we're told. From point B up to the equator is another 30 degrees, because we're 30 degrees south. Together, from point A to point B, we have a total of 60 degrees. So the distance between point A and point B would be using that arc length formula, pi times 6,400, which is the radius of the Earth, times 60 over 180. So here we have a quick little worked example. It says find the distance between Sydney and Rockhampton. Now what we're looking for in these types of questions is we're looking for either the same latitude or the same longitude. The two cities or the two places must have the same latitude or longitude. In this example, they both have the same longitude, 151, 151 east for both of them. So we can go back and we can draw our little picture. We've drawn our 3D picture here. There it is there. So we have Rockhampton and Sydney drawn on. So because we are 34 degrees south for Sydney, it is further south than Rockhampton, which is only 23 degrees south. Remembering that we have the equator in the middle here. So that would represent 0 degrees. Okay, so from that equator, from the orange line down to Sydney, we have 34 degrees, and from the equator down to Rockhampton, or the red line, we have 23 degrees. So looking now at the simplified diagram below, at the circle, what we've done is we've drawn on the equator, represents 0 degrees. We know Sydney is 34 degrees south. We know that Rockhampton is 23 degrees south, so we've drawn that on there. So what we're really looking for is the angle difference, or the difference in angle between the red line and the green line, or Rockhampton and Sydney. So the difference there is 11 degrees. We have another little diagram that shows that underneath, and again the distance equals the arc length. Okay, so now we're going to look at longitude. So remember, going back to latitude for a second, latitude were the flat lines, the horizontal lines that go up and down the Earth. The longitude are the up and down, or the north and south lines. These are measured from the center of the Earth to the east or west. So before, with latitude, we were measuring north or south of the equator. With longitude, we're measuring east or west. In this case, we're not measuring from the equator, we're measuring from another line that represents 0 degrees, and that is called the prime meridian. That represents 0 degrees, just like how the equator represented 0 degrees with our latitude. So here, the prime meridian, it's a line that goes through Greenwich in England, and we measure our degrees east or west from that line. So that represents our starting point. So again, the South Pole, just for a bit of reference, South Pole down the bottom, North Pole at the top. And again, we are measuring either east if we're going to the right-hand side, or we're measuring west if we're going to the left-hand side. And that is always done from the prime meridian. 90 degrees would be right on either end. And if we go all the way around and do half a turn, we've done 180 degrees. Okay, so you'll notice that if we're looking at the eastern longitude, we start measuring 30 degrees, 45 degrees, 60 degrees, and so on, until we get all the way around to 180. And if we go the other way, we're measuring the exact same angles. So 30 degrees, but now we're west. So this would be 30 degrees west. This would be 45 degrees west, 60 degrees west, and so on and so forth. So what can we do with this longitude knowledge? Well, again, we have our drawing at the top here. We have our reference point, which is our prime meridian. The South Pole would be at the bottom there of that sphere. Prime meridian is our 0 degrees, and we're given again 2 points, point A and point B, and we're given the longitude of these 2 points as well. We're told point A is 15 degrees west, and we're told point B is 45 degrees east. So we're asked to find the distance from point A to point B. So again, we've simplified the diagram just in here. Down the bottom, we have point A, drawn on, 15 degrees west. We have point B drawn on, which is 45 degrees east. And again, we're looking for that arc length, the distance around the outside of this circle, which represents the distance from point A to point B. So when we are on two different sides of the meridian, we have to add the angles. So we do 15 plus 45 degrees, we add the angles. If we were on the same side of the meridian, we would have to find the difference between those angles. So we would have to minus the angles. And again, our formula that we use, our equation that we use, is the arc length equation. So here we have an interesting question that gives us again 2 points, point A and B. We're given the longitude of these 2 points. One is 120 degrees west, one is 140 degrees east, and we're asked to find the shortest distance. It's very important to note that it says the shortest distance. We could simply find, if we draw on our 2 radius lines, we could find, using this angle, we could find the distance around the outside of the Earth. However, that's not the shortest distance from point A to point B. The shortest distance would be going the other way around the outside of the Earth.